The project that we're working on is part of this thing called structure as sensors. So in general, when you think of a sensor, what do you think of? You think of a small thing that's inside, for example, a microphone. That's a physical element that moves and you're transferring that to electricity to understand what's happening. Here, the physical element is the entire building. And based on how the entire building responds to the physical world, we can understand things like the people inside that building. When people walk around, they create these tiny vibrations on the building, and we use the building to sense these people. So the impact of the work is actually we're changing the entire physical world into a sensor. So the world can understand who you are, where you are, and how you're feeling at certain times. So the building, for example, could become more empathetic to the user's need. I see the most impact actually in the medical domain, where people need to recover and we need to quantify their recovery stage. For example, if we have an elderly, we can understand how much they're walking, their activity level, and how much more activity can they do before they're about to fall. So it goes from the low end, from getting the sensing, how do you capture the minute vibrations that's in the building. From the building itself, how does the building itself propagate these vibrations to the users? How does the user create these vibrations, and putting all these things together, what do they all mean? My part is basically trying to capture the sensing information from that. How do you capture the minute sensing information and maximize the information captured from multiple sensors located at multiple points in the building? Professor Hae-Yong No is actually the structural engineer part, where she's trying to figure out, okay, how does all these waves propagate inside the structure? How does the structure affect all these waves? And together, all of us are trying to make sense of what the final product actually means. Part of that, the project, we're trying to build figure out the location of the user. We're trying to understand the identity of the user, and we're trying to obtain the characteristics of the user as well. And that will also require collaboration with the medical side, which they can help with what does these things mean to the user, and then we can actually get the final result to the doctors. The next stage we want to actually figure out is characteristics of people. We are trying to understand the balance, trying to figure out the emotional state, trying to figure out perhaps stress level that's reflected in the gait. So these small or minute things that involves more of an understanding of the human. I think that's actually the ultimate challenge. So for the project right now, what we have done is figure out the identity of the person and the location of the person from the structural vibration. And what is that? That is basically Harry Potter's Marauder's map. Basically what we have is on a map, we see footsteps with the name attached moving inside the building. We are building magic here at CMU, but we're actually doing one step better because we can understand what the user is actually thinking and feeling.